Our discussion, let's look at the scientific systems of measurements. We talked about experiments. Experiments are going to involve measurements. So again, observation is going to be quantitative. They describe with words: hot, red, large, talking about what you see. Quantitative describes with numbers: 100 degrees, 10 meters, 3.46 grams. Scientists, for the most part, prefer quantitative, right? Prefer the numbers because they're easy to agree upon and have no personal bias. Hot, large, there's a bias there. Right? Large to me may not be large to you, but we can agree on the numbers. So measurements, a number without a unit is meaningless. All right, so if you tell me it's 4, the question is for what? 4 meters, 4 degrees, 4 apples, for what? There has to be a unit behind that to tell me what you're talking about. Scientists use a metric system, or the SI unit, the System International Units, is the unit that scientists use. It makes sharing data quite easy because we all understand what those units are. There are other units. We are familiar with the British or the English system because it is widely used here in the U.S. Miles, inches, pounds, seconds, degrees Fahrenheit, those are British system units. Metric systems, which is used throughout the rest of the world: kilometers, meters, grams, degrees Celsius, they use the metric system. The measurement of space in any direction is usually three-dimensional: length, width, and height. In the metric system, that's going to be measured in meters. In the British system, the standard unit is going to be a foot. Mass, the amount of matter an object contains. By definition, an object's mass is always constant, meaning no matter where I take that object, that person, it has the same amount of mass. If I take it to another planet, the mass stays the same. Mass is what we call a fundamental unit that will remain constant throughout the universe. The metric standard for mass is kilograms.